Yep. Good evening, everyone. So last session we discussed the TypeScript basics. So I explained the changes in JavaScript and TypeScript. Variables are same, but data types are strongly typed. We learned about how to declare variables and define the data types. Operators are same. Operators, statements, and the functions, what changes are there, I explained them. In data types, how to declare object, how to declare arrays, and how to manage functions with optional parameters. These all points. So these are basically almost similar like JavaScript, but some changes in the data type, how to define data types important. Now, what is new is TypeScript. Object-oriented programming is new. TypeScript OOP concepts are little different than what you know in JavaScript. Actually, in JavaScript, object-oriented programming means you might have learned only class members, how to handle inheritance, polymorphism like. But here, some new points are there you need to know. Actually, the first important in TypeScript OOP, you need to know contracts. In every object-oriented programming, we have contracts. Contract means actually, when you are designing a component, any component that you design have to follow certain rules. Without following rules, we cannot simply design a component. For every component, we need to configure rules. For example, one concept I will explain. Suppose here, the concept here is, suppose you are working in a company, and here the role is, your role is to design database. You have to design database. Database contains tables. So with rows and columns, you need to design a database. You have to design database for any particular project requirements. For any project, you need to design a database. Now tell me, to create database for any project, what is the prototype that you refer? What is the prototype that you refer to design database for any project? Prototype means, will you design database simply like that? There must be some reference for creating database. There must be some reference for creating database. That means what tables must be, what fields must be in table, what should be the data type of those fields. All these rules are mentioned. Can you tell where those rules are mentioned for designing database? Question understood? To design database, you have to follow certain rules. For a project, what tables are required, what fields are required in those tables, what data type must be for those fields. All such rules are mentioned. Can you tell where they are mentioned? For general database, if you are using Oracle, MySQL, SQL Server anywhere, To prepare a database in any software company, you are provided with database models. You have database models. Generally, we have database models. I hope you people know database models we have, like conceptual model, like physical model, like logical model, like entity model. You heard entity diagram. You heard about entity diagram while working with database. What is entity diagram? Entity diagram contains the complete information about what need to be in database. That means what are the tables you have to create, what are the fields you have to keep in those tables, what should be the field name, what should be the data type of that field. All that information is present in, you people call it as ER diagram. You know, we have a ER diagram. For that ER diagram, we prepare the database. That means in that ER diagram, we mention all the information. Actually, that is an order. There will be certain order. First, we prepare conceptual model, then physical, then logical, then entity. No need to explain them now, because you just need to know that any concept is not designed just by imagination. To design a concept, there must be certain rules defined for that. There must be certain rules defined for that. For designing database, rules are defined in which location? ER diagram. Now, this, according to this diagram only, our developers will design database. According to that diagram only, our developers will design database. For example, actually, I will show you. It looks like this. Generally, it is like this. You see, database models look like this. These are database models. This is example of a database model, some project related. Actually, first what we do, we prepare a physical conceptual model. Conceptual model means we will decide what are the modules that need data. After that, we design physical model. Physical model looks like this. In physical model, we design what should be table name, what should be the field name, what should be the data type. After that, we design logical model. In logical model, we design relationship. Is there any relation between one table and another? What are the fields related, primary key, foreign key, and all. After that, we prepare entity model. This is the ER diagram. This entity model is given to a software developer who is designing database. Any database designer in real-time projects have to prepare the database according to this diagram. He cannot miss anything from here. He cannot add anything by his own, which is not mentioned here. Exactly what is defined here, he need to define there. That means now developers will follow the rules of this diagram. According to that, they will build a database. Now, what is this ER diagram? ER diagram is nothing but it is a contract. It is a contract for designing database. To design database, we need a contract. Similarly, in order to design any component in object-oriented programming, To design any component, we need contracts. Actually, a contract defines the rules for designing a component. That means what are the basic rules for a component? Those rules are defined by using contract. Now, in general, people who are learning OOP languages, they know these contracts as contracts are known as interface. They known as interface. General people know these as interfaces. That means in software company, if anybody asked, you learned some OOP language, C++, Java, .NET or something. If anybody asks what is the purpose of an interface, in any object-oriented programming language, what is the purpose of interface? The purpose of interface is to design a contract. Architectural way, we call them as contracts. In general, people call them as interfaces, right? So learners always use the word interface, but experts use the word contract. So you need to design a contract for designing a component. Those contracts are called interfaces. Generally, actually, interface defines rules. Interface defines rules for component. It defines rules for component. How a component should be, what values it should take, how it should work, everything is decided by interface. It is decided by interface. So you cannot do anything other than what is mentioned in interface. What is defined in interface, only that you can do. Other you cannot do. That is the point about interfaces. Interface. For example, see here. That means here the key point is, suppose I am creating LED product. Yesterday I showed you. So here in the product, I mentioned some data. I'm not mentioning data type. That means it will be by default what type? Any. I'm adding some name. In that I mentioned some number. It is taking. I mentioned some price. In that I added some string. It is taking. But I need to restrict. I need to set some rules for this. Yesterday, what we done? We created a data type. By using the data type, we mentioned what type of data it can handle. Now, what you can do, you can create a contract. You can create a contract. For example, you saw, observe, if you remembered yesterday what I showed you. Now we see, suppose this is fake store. In fake store, we have products. In products, we have a product one. This is one product information. Now I need to handle this product. If I need to handle this product, how to mention data type? That means it should handle ID, ID number, title, string. Then as per yesterday's concept, how to create it? We need to create LET product. Here we have to put a curly brace, am I right? What is that? First property, ID. ID what type? Number. After that, so we have title. Title is what type? String. After that, so we have like this price. Price is again what type? Number. Like this, 10, 15 fields I have to mention. Suppose you saw NASA API. It was more fields. Later, if I want to add one new rule, if I want to extend the rules, modify the rules, delete the rules, then making change in this type here is always difficult. Then in object-oriented programming, what we do is, instead of writing like this, what we can do is we can create a contract for this. How do we create a contract? Actually, contract is defined. It is defined by using interface keyword. That means we can create a contract like this. We have to use interface name. I will give as product contract. In this product contract, you can mention what are the rules. Here you can mention what are the rules. That means now see here, I am creating interface. Interface is product contract. And what are the rules? Rules, it should have name, string type. It should have price. What type? It is number type. It should have stock, which is Boolean type. It should have rating. Rating is object type with rate as number and with the count also as number, like this. It should have cities. It should be array. So it should be cities. It should be cities. What type? It should be string type array. That is how we can define. This is how we can define the rules. That means I am configuring like this. Now these are the rules to be used by this product. Then what we have to do is simply you can implement here colon. It should use that product contract. That's how we do. You will not write all of them in that data type. Now, this is how we design the contracts and use the contracts. That means if I want product type, then yesterday you saw directly we mentioned the types. But writing like that is okay if the values are standard. But if later I want to extend, I want to make some changes, then editing the type is difficult. But now editing interface is easy. That means why it is showing error? Because as per the rule, name must be string. That means I will put according to rule now. It is string. Price, I will put number. But still it is not satisfied. Why? Because stock is compulsory. We defined as true. And rating is compulsory. And rating is having two properties. One is rate, which should be a number, and another count, which should be another number. After that, still it is not valid because we have to mention cities, which should be, cities must be array of string type. So we have Delhi, we have Hyderabad, like this. We need to define like this. This is the good way. Now, what is the point here? Suppose I am not writing rating. I am not writing rating. It shows error. I want to make it optional. You know, you can put a question mark. Then it becomes optional. That means you can ignore. Otherwise, it is mandatory to define. That is the concept here. This is the concept. So yesterday, it's okay. You return the type for an object. But if types are to be changed, they need to be extended, then it is not good. Then how do we define the rules? The rules are defined by using interfaces. We call them as what? Contracts. That means now you design a contract and you implement the contract. That means you are creating a product and it can use that product contract. According to the contract, it should have values. Now, very important is interface can contain only rules, not definition. It contains only rules, not definition. That means in interface, name is string is equal to some TV. This is not allowed. That means interface cannot contain values. It contains only rules. Only rule what is allowed and what is the type. It cannot contain what value it should have. That means you cannot put any values, only rules. Interface can contain only rules. Another important actually. So here interface can have optional rules. You know that optional rules which are defined by using what? Question mark. Interface can have optional rules. Optional rules are defined by using question mark. You can have a question mark. That is optional rules. You can configure optional rules. So while working with interface, this is very important. We can configure optional rules. The question mark is used for optional rules. You know, we can just put a question mark. Question mark indicates it is optional. It is not mandatory, right? So now this is one point. Let me give you this syntax. Means how to write an interface, how to set the rules with optional features. These are the points. But still, it's not finished. A lot of points are there. Actually, another important point is interface can have read-only rules. Interface can have read-only rules. Read-only rules means actually when you are writing a type, you cannot make read-only. But while you are using interface, you can make it read-only. Read-only rules, interface can have read-only rules. Read-only rules means nothing but once the value is initialized, it cannot be reassigned. Once the value is initialized, it cannot be reassigned. It cannot be changed now. That is called read-only rules. Read-only rules means see. Suppose now let's say simple one. So interface, product, contract. Okay. You can give any name. Just reasonably, I am giving contract word for that. Here we have name, which is string type, and the price, which is number type. But for this price, I will give read only. If you give read only for any field, what is the meaning here is, suppose I am using LET product. It is using which contract? Product contract. According to that name I mentioned. So name I mentioned some TV. After that price I mentioned some 63,000. After that, what I am doing here is I am printing these details. Console.log. I am printing name is equal to, so product dot name. In the next line, price is equal to product dot price. Okay. Now for your just convenience sake, I am opening this in a separate command prompt. Actually, you have to compile from terminal. I am just roughly using command prompt so that you can cleanly see it. Here, first, what we have to do, tsc index.ts. After that, node index.js. Now you can see name and price are printed. Suppose I want to change name. I want to change name. So after the name is assigned to TV, here I am accessing product dot name is equal to Samsung TV. I am applying. Now it will be okay. You can change any number of times. You can change any number of times. You see now, I compile this again and run this, and you can see it is changed. Similarly, I will try to change price. Product dot price is equal to some new price 70,000. It is not allowed. It will not allow. Why? Because price is configured as read only. Read only means once you assign, you cannot, once you initialize, you cannot assign any value. What you initialize, that is final. You cannot assign. Suppose if it is not read only, if the price is not read only, now it is okay, it works. If it is read only, if it is marked as read only, you cannot modify. This read only like words you cannot use while writing type, right? That is the reason we officially use contracts, and these contracts we use as types. So that is how we can manage the perfect data, so that it will be structured. It is not schemaless, structureless. So this is actually how you can configure the price. That is read only. That means now this is invalid. Why it is invalid? Because it is read only. You cannot assign. This is example. This is one important point you should know. So that is an example. So interface can have optional properties. Interface can have read-only properties. You can have read-only. Read-only properties are defined by using the keyword read-only. Read-only. Another important is interface. Interface can have rules for functions and methods. If it is class, you can set rules for methods. If it is object, you can set rules for functions. That means interface can have rules for functions and methods also. Currently, the interface is having only rules for properties. Here, two properties are there. What are those? Name and price. But actually, interface can contain rules for methods also. Interface can contain rules for methods. It can contain rules for methods. How it can contain rules for methods? For example, you see here, suppose I am giving here interface product contract, and here I am writing name must be string, price must be number, quantity must be number, and total is a method. Total is a function which calculates the total and returns the total. It should return number. Then how to write the rule for a function? We have to write a parenthesis, and we have to put colon, and we have to tell what is the type it should return. This indicates that total is a method that must return number. That is the rule. That is the rule defined for methods. Rule defined for methods. Now I am adding print. Print is another method which can be void type. That is the rule. Remember, here you cannot tell what functionality. Functionality cannot be defined. Here it can contain only rules. That means you cannot have functionality. That means you cannot write what functionality it should have. Functionality is not there because A contract contains only rules. And if you want, you can make these methods also optional. You can make the methods optional. A property can be optional, a function can be optional. So here you are writing the rules for properties and functions. I'm calling functions methods, no confusion, because if I am not using in a class, it is a function. I'm using in a class, then it is a method. You may ask, like, can I use this contract for a class also? Yes, that I will show you how a class uses the contract. Currently, object is using na LET product. Product is an object which is using which contract? Product contract. In this contract, it should have a name and it should have price. Price must be number, and it should have quantity. Quantity also number. It should have what? Total. Total is a function. This total function is showing error. Total is a function. It is showing error. I will write like this. Total. Total is a function. You have to write a function. And this function should return a number. This function should return a number. Because you see total says that, so you are currently using void, but it should be number. Currently, I am not returning anything, then it thinks that it is void type. How to return? We have to use return this dot quantity into this dot price, which will return a number. Now, for example, if this function actually, for example, if this function is returning, it is returning some string, it is invalid. Because as per the rule, it should return string is not assignable because its type is number. It should return a number. It should return a number. Now we need another function that is to print. Print is a function. This function is a void type. It can print all details. Console.log name is equal to, suppose I am using product, this dot name, because I am writing inside the object. In the next line, price is equal to this dot price. In the next line, I am defining quantity is equal to this dot quantity. In the next line, we are writing total is equal to this dot total. Total is a function. We have to write like this. Now I want to access the print method. Then we have to use product dot print. That is how we define. Now, and very important, this product dot print. So product dot print, you can see it is showing that cannot invoke an object which is possibly undefined. It is saying that you cannot invoke this, but it's okay. It is just a warning. It is saying that don't directly try to access this, use in some class or somewhere. That is not an error, no problem, it will work. What you have to just do, you have to compile this TSC, what is it? Index.ts, and we say node index.js. It will print those details. Remember, don't get confused with those error messages. You compile here and see, because those messages are related to warnings in code. If you are not following coding standards, it will show error, but we can still run them. If it is really a syntax error, then it will show here in command line. It will show that it is an error, right? Don't worry about the errors which is showing with red underlines in Visual Studio Code. Those are just only hints, right? Error means the error should come here. If it is compiled and it is showing error, then that is error, syntactical errors, right? Otherwise, don't worry about them. Directly run them, they will work. Okay. So this is the concept of how we can define the rules for functions and methods. functions and methods. But important here, currently you are applying for where? Currently we are applying on object. Later we can apply on any class. I will show you how to apply on class. So what is the purpose of a contract? Purpose of a contract is to define rules for designing any component. And rules can be optional, rules can be read-only, and rules can be for a property, or rules can be for a method. Can be for a method or a function, right? Another very important actually. So contracts, interface can be extended. Interface can be extended. You can extend an interface. Interface can be extended. That means actually, so you can see here, already we created a contract. In this contract, name, price, quantity, everything is there. Later, I want to add one more new rule to this. If I want to add one more rule to this, I don't want to disturb the existing contract. So already we learned in inheritance concept. Backward compatibility, I explained in inheritance backward compatibility. That means we don't want to disturb this. We want to add a new rule to this. How? Without disturbing, how you will add a new rule to this? So we will create another contract. So interface, I will create a category contract. This category contract is having category name. Category name, it is what type? String type. Now this category contract should able to use all these product contract details also. Then what you can do is category contract extends which contract? Product contract. It can extend product contract. Now what is the point? If you implement category contract, it will give access to all. Same like you have super class, you have a derived class. This is a super contract and this is a derived contract. Now what you have to do here? Now the product have to implement which contract? Category contract. Now according to category contract, product is missing category name. Product is missing category name. Because in the product contract, all other details are there, you implement it. But in category contract, category name is there, that also you have to implement. So I will write here category name. Category name is what? Category name. Category name is so any name like electronics, You know the basic rules, like there is no order for the members, no? That is not a question at all, right? Can I write price first? You can write anything first, second. That doesn't matter. That is a very common sense, basic thing. Everybody knows in HTML, attributes, properties, they don't have an order, right? You can write first this, second this, third this. These are not parameters. Only parameters have order dependency. I hope you know that. You learned JavaScript. Parameters have order dependency. Members in a class and members in a contract don't have any order dependency. But parameters in a function or a method, they have order dependency. You have to write in the same order. That is general thing in JavaScript. Huh? Now here we need to print contract, this category name. I will add that also here in the next line. So category is equal to this dot category name. We are printing that. That means now we are able to extend the contract. So compile this again, and we have node index.js, the category name. So without disturbing the existing contract, we can extend a contract. You can extend the contracts like this, multi-level. You can even extend the contracts multiple. It supports multiple inheritance, multi-level inheritance. That means interfaces will support multiple inheritance also. So a interface can be extended multiple or multi-level. It supports single, multiple or multi-level. Multi-level means what? Syntax, we have an interface. Suppose this is interface name, and it can extends interface 1, it can extend interface 2, it can extend interface 3, like this it can do. It can extend any number of interfaces, which is not supported for classes, but this is supported for interface. That means you can extend multiple contracts. You can create one contract extending multiple contracts. That means, for example, first I will give this example. And you see here, suppose another example is, suppose we are defining like, so interface, suppose HDFC, so version 1. In that HDFC version 1, I given as, suppose here personal, it is a string type. NRI, it is a string type. Now what happens is interface, this is HDFC version 2. Now in this version 2, for example, there is another option. For example, we have some loans and it is string type. Now what happens here? We have an interface called bank contract. This bank contract extends HDFC version 1, HDFC version 2. This is multiple. And here we have name, bank name, it is a string type. That means now you create an object, LET HDFC is what type? Bank contract type. Then it should implement all the features. All the features means version 1, version 2. This is multiple inheritance. That is multiple inheritance. That means it should be able to implement all of them now. So that means here you are defining. So what is it? It should have a bank name. Bank name is what? Suppose I say HDFC Bank. And it should have so personal. So this is what is it? Personal, right? Yeah. So we have like personal, and this is what type? Some personal banking. This is an object now, right? And we need another one, NRI. This is what? NRI banking. And we have like loans. That means here some loans, some housing loans, like this. This is all multiple. That means you can create a contract that can extend several contracts. So here I am just giving them, you can print them. So console.log, you can print all the details. Of course, it is an object now. You can try like this for where property in. What is that? HDFC. It is an object. You can print console.log. You can print the property. We can print the property and we can print the value. We can print the value also. How do we print the value? Here we have to say HDFC of property. It will print the value of that and it will display. That's how we can configure. What is it? It is object type, because it is a contract type. That is the reason it is not supported. We will print here the properties here. Yeah. All the properties we are configuring. Let's say, let's run this. Yeah. So index.ts and node index.js. It will print all those details. Now you want to read the values of them, then you have to print all the values, right? Actually, so to print the values, we need to use another option like this. What is that? We need to define the object name. Object name is HDFC, and we have to define HDFC. What is it? Property. It should get the property and display, right? Now that property is going to access the data and display. Let's run this and see now. So we have TSC index.ts and the properties and values. It will print all the details. That's a very basic thing. Already we know generally how to deal with the objects, right? So it is going to access the details and print the details and display them. This is a simple basic point. That is the example how you have to handle. Okay. Objects are accessed with reference of properties. You know, JavaScript destruction technique. This is extending of contracts. That means these all things you cannot do just by mentioning data type. That is the reason we separately create the contracts and we separately implement the contracts. So this is one new thing which you don't have in your general JavaScript. That means now if you remembered when you created use state and you are trying an object here, understood? You are doing that, right? That means now this object contains what properties? If data is coming from an API, it contains what properties it should deal. If you don't mention the properties, then it is unable to handle. Then you might have seen even previous examples. You have to mention the properties now, right? Now we will just put here our contract. Understood? We use our contract. That contract is interface. That means now it should able to handle the values of this type, the contract type. That is how generally we do. That I will show you when you go into that TypeScript with React, then you can add like this. From hereafter, we use these contracts for mentioning the types, what they have to handle. So this is the basic thing about how to deal with contracts in object-oriented program. So this is not there in JavaScript, that you have to use in TypeScript. Okay. Next important in TypeScript after contracts, another option is class. Class is same. That means in JavaScript also you have class. How to declare a class, what are the members in the class, but here some new points are there. Little change in the classes here. What is the change in the classes of TypeScript? Actually, the change in the class, I already explained detailedly in the beginning. Class is a template, what it will do, access module, what is accessors, properties, methods, constructors. Can we have a function in class? Can we have an variable in class members? Already those rules we learned. But here several new points are there. The new points, what are the new points in TypeScript is, first thing is TypeScript class can have static and non-static members. JavaScript class don't have this concept. So TypeScript class can have static and non-static members. Actually, what is the meaning of static in OOP languages? Static refers to continuous memory. Continuous memory. And non-static refers to discrete memory. Discrete memory. Static refers to continuous memory. Non-static refers to discrete memory. They refer to static refers to continuous and non-static refers to discrete. What is that? I will show you actually. In any OOP language, static, non-static members will be there. In JavaScript, we don't have, but in TypeScript, class can have static, non-static members. Actually, static members, if anybody asks what is the purpose of a static member, static members are used for continuous memory. Continuous memory means, so I will give you here first point. Static. Static is nothing but memory allocated for first object. Allocated for a first object will continue for next object. The memory allocated for first object will continue for next object. That is continuous memory. That is continuous memory. Actually, static members are defined by using static keyword. They are defined by using static keyword. And static members are accessed within class or outside class by using class name. They are accessed by using class name. Static members are accessed within class or outside class by using class name. What is the main concept of static? Memory allocated for first object, the same memory used for others. For example, when you need continuous operations, then you need to declare static. I will tell you one example here. Actually, the example about static, non-static, generally you should know that the word static and non-static are related to memory. The terms static and non-static are related to memory. If anybody is talking about static, non-static, that means they are talking about static memory, and they are talking about non-static memory means dynamic memory. Now, what is the nature of these two memories? I will tell you here. Suppose we have a class. So in this class, we have a static member S and we have a non-static member N. We have two members. Now what happens? The memory is allocated for this class. When memory is allocated for this class, the static member will be stored in static memory. So that means now S is here. Now suppose S is initially 0 and here S is initialized to S plus 1. And non-static means it will go into dynamic memory. N is 0, N is equal to N plus 1. Both are incremented by 1. Now what happened is you created an object. You created an object 1, obj1. You created an object for first class. You created an object for this class. And this object, what it will do is that object will go to static memory and it will use this S. Now what this object will do is it will change the value of S is equal to, it is equal to 0 plus 1, it will be 1. After changing the S value to 1, it will keep that memory like that and it will come out. Memory is still available. But when it goes to dynamic memory, it will put N equal to 0 plus 1. That means N equal to 1. After that, it will reset the memory. Dynamic memory resets. Static memory continues. That means dynamic memory disconnects. static memory continuous. That means now what happens for object 1, S is 1 and N is also 1. Now what happened is object 2 is created for same class. When object 2 is created for the same class, object 2 is created. Now object 2 will go to this memory. It continues the previous memory. It continues the previous memory means S will be how much? S will be 1 plus 1. That means S value will be how much for object 2? It will be 2. But when it goes to dynamic memory, it resets. That means again it will be 0 plus 1. That means 1. That means for object 2, S value is 2, but N value is still 1. You create any number of objects for that class, static member continues and non-static will disconnect. It will reset every time. That is the nature of static and non-static. Static uses a continuous memory and non-static uses an discrete memory, disconnected memory. And generally, if anybody asks, where do we use this? Very simple. For example, you are using Gmail. In Gmail, once you logged in, you don't need to log in for checking every mail. For every mail, it should continue. Once you logged in, it should continue until you log out. But when you are using some bank application, you finished one transaction and you went to another transaction, it will ask password again. That means after the transaction finished, your password is disconnected. For another transaction, another again password you have to mention. That means every time it connects and performs the operation, then it disconnects. If you need continuous operations, then you go with static. If you need disconnected operations, then you go with dynamic. What is problem with static? It uses more memory. It is not safe, but it is good if it is required with continuous operation. Dynamic is safe, but it is not continuous. Every time you need to connect. That depends on situation we use. For example, see now here. So what is non-static? Non-static is nothing but, so memory is allocated for every object individually. That means they are disconnected. They are disconnected in access. That means discrete. Very important. So non-static members are accessed. Members are accessed within class using this keyword, and outside class using instance of class. Instance of class means object of that class. But static members are accessed inside or outside using class name. For example, let's prove this point here. See, I am creating a class demo. In this we have static S is 0 and non-static N is also 0. If you use the keyword static, it becomes a static member. I created a constructor. In the constructor, this is same like JavaScript constructor. Now what happened is demo.s is equal to demo.s plus 1. And this dot n is equal to this dot n plus 1. Why? Because it is non-static. Both are incremented by 1. Static is accessed by class name. Non-static is accessed by using this. Now I will write a print method. This print method have to print the details of S and N. S equal to, so demo.s, and N equal to this dot N. We are printing the details. Okay, let's create an object. obj1 is equal to new demo. Through obj1, we are printing. First object is printing. second object, obj2, we created second object for same class. This object 2 is also printing. We created object 3 for same class. This object 3 also printing. So also printing. We created all these objects. That means the first object, the second object, the third object, all these objects are printed. Now all these objects are defined. Now what happens? Let's print this and see. Remember, all objects are using same class memory. But S is using static memory, N is using non-static. See what will happen? TSC index.ts, and we have node index.js, and you can see S value is incremented by 1, 2, 3, but N is always 1. 3 different objects, but they are continuing. That means S2 is printed by second object, S3 is printed by third object. Memory allocated for first. See, at real-time projects, means at high level, at experience level, if you say static is used to, static members are accessed by class name, non-static are accessed by using instance. This is what generally people give as definition. If you ask what is static, non-static, this is the definition you will hear from general OOP learners. And by that answer itself, we can know that he is a beginner or learner of the technology. Right? Experienced people answer about static and non-static is about discrete memory and continuous. We never say how it is accessed. Is it by class name or not? That is not the point. That means technically what is static? Continuous memory. What is non-static? Discrete memory. When to use static? When you need continuous operations. When you need non-static, when you need disconnected operations. That means the same concept actually. That is what I explained generally. Suppose we have operations to perform like insert, like insert, update, and delete. We have 3 actions. We need to perform 3 operations like insert, update, and delete. We need these 3 operations to perform like insert, update, and delete. Now what happens here is when you are dealing with those operations, suppose there is a database. Now we need to handle operations on this database. Now to handle operation on database, first thing is before inserting, updating, we have to connect first. That is important. After connecting, we have to insert or update or delete. But remember, suppose this connection is given as static. If the connection is given as static, what will happen now? Now you click insert, it will connect. After connecting, it will insert. After insert is finished, the connection is still in memory. The connection is still in memory. Now when you click update, it will not connect again. It will use that connection. You click on delete, it will use that connection. That is good. But if you are not updating and deleting, the still connection is in memory. It is not safe. Suppose you left your Gmail without sign out. Somebody opened Gmail on your laptop. Directly your account will open. How it is safe? Will bank details open like that? No. Even you forget to sign out, they will automatically sign out after few minutes. Right? But Gmail is not doing that. Until you delete, until you sign out or delete cookies, it is still continuing. So that is connected. That is not safe every time. Disconnected is good. But the problem here is disconnected is not good in continuous operation. If I make this connection as, non-static, then what happens? It will first insert, connect. After connection, insert. After inserting, this connection is removed. Now, when you say update, again connection will happen. After updating, it will disconnect. You say delete, again connection will happen. Every time you have to connect. If there are continuous operations, then this is a lengthy process to do. That is depending on that you can handle. This is a simple example to understand. Static and non-static members. These are all not a part of JavaScript. Now you can utilize these all in your React, because earlier you need to depend on a lot of state management only. But once you know about the static, non-static members, you can declare a static memory and you can use across components. You can manage this very well now. That means across requests. I told you across requests data will be lost. Now data will not be lost if you maintain a static memory. Why? Because it will continue for others. This is lot of difference now. So that is the reason in working with the TypeScript based React environment. So you should know some new things, how we can manage in a better way, right? This is one new concept about class. So what is new about class is class can have static and non-static. Another important new thing is class can have access modifiers, which is not there in JavaScript. Access modifiers for members, what are that? We can use public, we can use private, and we can use protected. We have public, private, and protected. These are access modifiers. Whenever you declare a property, whenever you declare a method, you can set the restriction for that. What is public? I hope you people know. Public, it is accessible by accessible from any location. From any location, it is accessible. Private, it is accessible only within the class. Within class, it is accessible only within class. Protected is nothing but it is accessible within the class. So so within derived class, only by using derived class reference. This is the rule actually. It is accessible within the class and it is accessible within derived class only by using derived class reference. What does that mean? I will show you here. Suppose you see now, I am creating a class called suppose some super class. In this super class, I am adding some public. So name is a string and some name. I am giving private as price as number and put some number. And I am using so protected stock. So that is Boolean and Boolean. So Boolean and say true. Like this we define. Now I need to access these members. I will create a class called derived. This derived class extends which class? Super. Now in this we have a print method. This is a print method. So this is like public print method. Now what happens is outside I am creating an object for so new derived class. For derived class I am creating an object. Now tell me through this object which member I can access. It is a derived class object. By using this derived class object, which member I can access of from base class? From base class, which member I can access? I can access only name because it is only public. Private is not accessible. Protected is not accessible. You see now, OBJ, I can access only name. I cannot access price. I cannot access stock. Only public member is accessible. So that is public. Now, how protected member is accessible? This is very important. Remember, here in the derived class, I created an object for which class? Super. Now, which member I can access? I created an object for super class. Which member I can access? Again, here also I can access only public. This protected is not accessible. Why? Because protected is accessible in derived class using derived class object. For example, you say obj dot, only name is available. If you want to access a protected member, this protected member is accessible in the derived class using which object? Derived class object only. Derived class object means this object is derived class. If the object is derived class object, through that object, we can access that stock. Remember, you cannot access through derived class object outside derived class again. Only inside derived class using derived class reference. Derived class reference means it can be like this also. You can just keep here obj, it is of what type? It is derived. And through that obj, I can access name and stock. I can access name and stock. So you observe carefully, you created a derived class object outside derived class. Outside derived class, it is not accessible. So what is the restriction of protected? Protected is accessible within derived class only by using derived class reference. Only by derived class reference. That means you can access only by obj name. You can access obj dot what stock. So protected member is accessible within that class. Within the class, all are accessible. Public, private, and protected. And protected member is accessible outside the class in a derived class only by using a derived class reference. That is the restriction of protected, right? This is all the types of protections we have through access modifier. This is not at all available in your JavaScript. Here we can define these types. Now, contracts means interfaces. In classes, static and non-static members, and access modifiers. Access modifiers. Properties, methods, constructors, same, no change. They are same. How do you write properties? How do you write methods? How do you write accessors? And how do you write a constructor? Everything same, no change. Only the difference is for methods, you have to mention data type, public, method name, data type, what it should return, void type or return type number or string, same like function you have to define. Rest of all options are same. Only the new concept is about the members, static and non-static. Another one is access modifier. Another important, now you can see here how the class implements contracts. How the class implements contracts, how the class uses abstraction. This abstraction is not there in general JavaScript. How it uses abstraction. And of course, inheritance and polymorphism are same. Inheritance and polymorphism is same like you have learned in JavaScript. Here additionally, you will see abstraction. How we can deal with abstraction and contracts, that we will see in next session. Then with that, we will finish general basic OOP. You have we have generics, we have enums. These are all TypeScript related new concepts. We will try to finish that in the next sessions. So working with abstraction, generics, and enums. If we know that, then we can start this TypeScript in React. We can build application with TypeScript. These topics we will discuss in the next session. Okay, right? And tomorrow we don't have session. Again, our session will be on Monday, right? So tomorrow we are giving off because of Shivaratri, right? And again we will come on Monday. Okay, right?